Lesson 10 is on residuals and residual plots. In lesson 9, our last lesson, we talked about the correlation coefficient and how it measured the predictability of the model. Please remember that the correlation coefficient, we use the variable R, and it ranged from a -1 to a 1. -1 or +1 meant that the model was a perfect fit for a linear relationship. If our correlation coefficient or our R value was 0, that meant that there was no linear relationship between the two variables. Although the correlation coefficient is an excellent measure, it does not tell us whether the model is appropriate. It only tells us whether it's good at predicting. Today, we're going to examine residuals and residual graphs, and they will tell us if a linear model makes sense. So the things to remember entering into this lesson, once again, is that a correlation coefficient tells us about predictability, whereas the residuals will now tell us whether a linear model is appropriate. So let's look at example 1. A skydiver jumps from an airplane, and an attached microcomputer records the time and speed of the diver for the first 12 seconds of the diver's freefall. The data is shown in the table. So here you have your X, your time, and then your Y, which is your actual speed, or the skydiver's actual speed. Part A, find the equation for the line of best fit for this data. Round both of the numbers to the nearest tenth. Also determine the correlation coefficient and round that value to the nearest hundredth. Finally, based on the correlation coefficient, determine how well the fit is and whether it's positive or negative. So take a few moments now. You're going to pause your computer. You're going to enter your X into your L1, your Y into your L2, and then you're going to find your line of best fit using Stat, Calc, and then you'll want to use option 4. So pause the video now and please find these values. So hopefully your line of best fit is Y equals 6.0x plus 13.1. Correlation coefficient is a positive 0.94. So how does that characterize the fit? Well, it's positive. And since it's awfully close to 1, we would say that it is a strong positive relationship between time and speed. I'm going to pause now this video, or stop this video now, give you a moment, okay? And then we're going to go on to part B.